All right, so constraints apply to a system of inequalities, and a constraint means that you're setting a limit on the inequalities, because some inequalities can have infinite answers because they just keep going on and on and on. So you're setting constraints, you're setting limits for the inequalities. And so the trick with setting these constraints is, first of all, actually writing the constraints in the first place. But then when we're going to graph them, it becomes tricky in shading them. So I'll talk more about that when we get to that part. So I'm going to use this example, and it's the same example we did in class. At least now you can kind of pause it and work more slowly through it if you need to. All right, so Grace wants to make and sell bead bracelets and necklaces. A bracelet uses 10 beads and a necklace uses 25 beads. Grace has a total of 150 beads left. She wants to make at least 2 bracelets, but no more than 4 necklaces. Write and graph a system of inequalities for the number of bracelets and the number of necklaces Grace can make. Because without these constraints, the idea is that she could just make as many bracelets and necklaces that she wants. But she has this limit on, she only has 150 beads, and she wants to make at least 2 bracelets, but no more than 4 necklaces. So you have these constraints that are limiting the number of bracelets and necklaces that she can actually make. So that's what we're going to do. We're going to write the inequalities to show us that, and then we're going to graph them. All right, so the first inequality that I'm going to write is dealing with the bracelets, because it says she wants to make at least 2 bracelets. Well, I defined X to be bracelets and Y to be necklaces. So for this inequality, I'm going to say that X is greater than or equal, because she wants to make at least 2 bracelets. So she'd be happy making 2, but she wants to make at least 2. So she'd be happy making even more than 2. For necklaces, it says she wants to make no more than 4 necklaces. So that's going to be Y is less than or equal to 4. No more than 4. So she'll make 1, 2, 3, or 4, but not more than 4. So that's why Y is less than or equal to 4. The next one is based on the number of beads. A bracelet uses 10 beads and a necklace uses 25 beads. So 10 beads per bracelet, which is X, plus 25 beads per necklace, which is Y, but she only has 150 beads left. So the number of beads that she uses on these necklaces and bracelets has to be less than or equal to 150. All right, so we're going to use all 3 of these constraints together to help us determine what kind of combinations of bracelets and necklaces she can make with the criteria. Okay? All right, so I am going to, you're going to have to bear with me for a second. It's easier for me just to snap a picture of this than it is to write it incorrectly. All right, so first thing I want to do, I'm going to graph this. And when I graph this, I'm going to actually start with the bottom equation, okay? And I want you to notice that this bottom, or inequality, not equation, I'm sorry, bottom inequality is written in standard form. So I can graph it based on the X and the Y intercept. The X-intercept is when Y is 0. So if Y is 0, then X is equal to 15. I'm going to come over here and I'm going to put a dot at the 15. Okay? The Y-intercept is when X is equal to 0. So 10 times 0 is 0, so that cancels out. So this means that Y would be equal to 6, because 25 times 6 is 150. So I'm going to put a dot at the 6. I can then connect my line, and because it says less than or equal to, it's going to be a solid line. All right. Okay, now, you wanted, if you prefer to graph slope-intercept form, this equation right here could be rewritten as Y is less than or equal to negative 2 x plus 6. I'll show you, here's my y-intercept of 6. My slope is negative 2 over 5. You can go down 2 over 5 and so on, okay? You could graph it either way. This is just how I prefer to graph it. All right, so now that I've graphed this line, I now need to shade it because it's an inequality. So one way that I think the easiest way is to just pick a point. Remember, we talked about you could pick any point. I like picking 0, 0. So if I pick 0, 0, I'm going to test because 0, 0 works, this inequality, that means I shade this side of the line. If 0, 0 work, that means that I'm going to shade this side of the line. So if I'm going to plug in 0, 0, 0 for x and 0 for y, that's going to be 10 times 0 plus 25 times 0. Well, 10 times 0 is 0. 25 times 0 is 0. So 0 plus 0 is 0. Is 0 less than or equal to 150? Yes, it is. That means this is the region that I'm going to shade in. And so I'm going to shade. And I know my coloring is not the best, so just stick with me. It's really hard to color on this tablet. Okay, so now I've graphed. So now I have graphed this bottom inequality. So now I'm going to graph the next one, which is y is less than or equal to 4. So I'm going to put a line. Here is y is 4. So this is a line for y is equal to 4. But because it's an inequality, I need to shade. And for this inequality, y is less than or equal to 4. If y equals 4, y is less than 4 means everything below this line needs to be shaded. Well, rather than shading every single thing here, we're really focusing with the shading on the areas that overlap. So I'm just going to shade in all of this that overlaps that we've already shaded that satisfied the condition of this inequality right here, okay? So I know, again, that this isn't the best shading in the world, but this is just, really, I should shade all this, or I could shade all this, but we're just focusing on the parts that overlap, that satisfy all the constraints, you know, all the conditions. So that's why I'm not coloring in all of this. I'm only focusing on what we've already colored in, okay? So now I'm going to graph x is greater than or equal to 2. So I'm going to draw a line at x is equal to 2. And here is my line. But because it's an inequality, I need to shade in, and I'm shading in where x is greater than or equal to 2. So this is x equals 2, this side of the line is greater than 2. This side of the line is less than 2. And because it was or equal to, that's why I have a solid line here and not a dotted line. So again, I'm shading on this side, but I'm focusing on what I've already shaded in. Okay? And so all of this that's shaded, the yellow, the pink, purple, and the blue, all satisfies the condition of making less than 4 necklaces, more than 2 bracelets, more than or equal to 2 bracelets, less than or equal to 4 necklaces, and then it has, these are the number of items that she can make with the number of beads that she has. Okay? Now, the next question that I want to pose, and this is based on this information, is that Grace plans to sell the bracelets for $5 each and the necklaces for $10 each. Write the objective function and determine her maximum profit. So we're just assuming she doesn't have any cost. We're not getting that detailed in it, okay? So her profit is going to be $5 per bracelet. Remember, we already said bracelets X, plus $10 Y. We are for each necklace because each necklace is $10, and Y we already decided was the variable to represent necklaces. This is how we can calculate the profit. And we multiply 5 by however many bracelets she makes, and then we multiply 10 by however many necklaces she's going to make, and we add it together. Well, if we come back and we look here, because it says write the objective to determine her maximum profit. That's the key word here, okay? So if I come back and I look at this graph, and I see, I want to look at my points. So like, it's going to be my maximum and minimums are all these points right here. These are my maximum X values and Y values, okay? So I have 4 points here. I have 2, 0. This means that 2 bracelets is the minimum and 0 necklaces is a minimum requirement based on the constraint. Or she could do 2 bracelets and 4 necklaces. She could do 4, which is 5 bracelets, 4 necklaces, or she can do 15 bracelets and no necklaces, and that still fits in with all this constraint criteria, okay? I'm going to plug in these 4 values for X and Y to determine what the profit is. So these 4 different scenarios, okay? So if she makes 2 bracelets and 0 necklaces, and I plug that into this formula right here, this equation, that means that profit is equal to $5 times the 2 bracelets plus $10 times 0 necklaces. Well, 5 times 2 is 10, plus 0 is $10. Let's say we look at this option of 2, 4. So that's going to be 2 bracelets and 4 necklaces. So the profit is 5 times 2 plus 10 times 4. Well, $2 for bracelets, $10 for 4 necklaces is going to be $50. So now we're going to try another combination. Let's try 4. All right, so we're going to try if she makes 5 bracelets and 4 necklaces. So $5 for 5 bracelets plus $10 for 4 necklaces is a total of $65. And then the last option we're going to try is this one where she just makes 15 bracelets and no necklaces. So that's going to be 15, 0. So that's going to be that's going to be $5 times 15 necklaces plus $10 times 0 necklaces, and that's equal to $75. So our question is, and determine her maximum profit. The option down here of $75 that gives her the most profit. So if she makes 15 bracelets and no necklaces, she's going to make the biggest profit.